Welcome back to The Explainer. So today, we're looking at a massive shift happening right now in how we interact with artificial intelligence. I mean, for the last couple of years, the entire focus has been on just talking to AI, right? Getting better at asking it questions. But what if the future isn't about talking to the AI at all? What if it's about designing the systems that actually manage the AI for you? Get ready because today, we are unpacking the fascinating world of loop engineering.
What if I told you that writing prompts, that thing we've all been obsessing over, is already becoming the old way of building AI? It sounds a little controversial for sure. We've all spent so much time learning how to craft that perfect prompt for tools like ChatGPT or Claude. But leaders in the AI space, like the head of Claude Code over at Anthropic, are actually coming out and saying they just don't prompt anymore. Instead, they write loops that prompt the AI for them. It's a total paradigm shift in how we get work done.
Okay, let's dive into this. Traditionally, the flow goes like this. You type a prompt, the AI gives you an answer, you read it, and then you type the next prompt. It's this very manual, single-shot loop where, honestly, you are the ultimate bottleneck. But in this new paradigm, you, the human, design a system. That system is what hands out the work to AI agents. It checks their work, and then it delivers the final results to you. You're basically moving from being a typist to being an architect.
All right, section 1, the end of prompting. To really understand why this shift is happening, we first need to look at the limitations of our current workflows, especially when it comes to complex tasks like software development. Think about the manual AI loop developers have been running for the past 2 years. You're treating the AI as a tool that you literally have to hold in your hand the entire time. It generates some code, you realize there's an error, you edit it, you prompt it again with the error message, and then you sit there and wait. You are the one manually closing the feedback app, and developers are hitting a major wall with this because it just doesn't scale. If you're doing the manual verification every single time, your productivity has a hard ceiling.
Moving on to section 2, anatomy of a loop. So what exactly is the solution? Well, it's loop engineering. Instead of you acting as the manager holding the AI's hand, you build an environment where the AI acts like an autonomous employee, one that just keeps working until a defined task is completely finished.
The difference here is absolutely profound. A standard chain is strictly linear, right? Step A leads to B, which leads to C. But a dynamic loop uses what researchers call the react pattern, reason and act. The agent actually thinks out loud, it takes an action like writing code, it observes what actually happened when it ran that code, and if it spots an error, it reasons about it and repeats the cycle. It doesn't just guess blindly, it adapts based on real-world feedback.
And this brilliantly illustrates the core phases of a well-engineered loop. It always starts with a strict goal. From there, the AI plans its approach, executes the work, and observes the results. But listen, the real magic happens in those evaluation and improvement phases. The loop must have strict success criteria to verify if the job is actually done. Plus, it logs its state memory, meaning it literally writes down what worked and what failed, so it self-improves on the next iteration without having to start from scratch.
Which brings us to section 3, the 5 components. If we were standing at a whiteboard right now, trying to actually build one of these autonomous loops, we would need 5 essential building blocks. Let's break down the anatomy piece by piece, drawing on insights from engineering leader Adi Osmani.
Component number 1, automations. This is literally the heartbeat of your system. Instead of you sitting there pressing a go button, automations find the work for the AI. You set up a schedule, maybe a cron job or a webhook, and the loop just wakes up on its own. Maybe it wakes up every morning to summarize CI pipeline failures or automatically triage new bug reports. The point is, it's proactive, not reactive.
Component number 2 is work trees. Now, if you have multiple AI agents working at the exact same time, you risk complete chaos. 2 agents trying to edit the same file? Total recipe for disaster. To translate the technical jargon instantly, it just means giving each AI its own isolated workspace, like a Git branch. They can safely work on multiple versions of the code simultaneously without stepping on each other's toes.
Next up, we have skills. This one is huge because without skills, your AI agent basically has a goldfish memory. It starts cold every single session and just guesses what your project's intent is. Skills are essentially a knowledge library, usually markdown files that write down your coding conventions, your build steps, and project rules. The AI reads this library every single time it runs, meaning it actually understands your specific, unique environment.
The 4th component is connectors. Because let's be real, a loop that can only read text files is pretty weak. Connectors, which are often built on tools like the Model Context Protocol, or MCP, are what let your AI loop interact with the actual real world. This is how your agent pulls a ticket from your issue tracker, queries your live database, and ultimately drops a quick message in your Slack channel to tell you the job is done. Finally, component number 5, subagents. You need specialized helpers. So the crucial point is, you never want an AI model grading its own homework. Seriously, it is way too nice to itself. You have to split the labor. You set up a maker agent that writes the code and a completely separate adversarial reviewer agent that checks the work against your strict rules. This separation of powers is literally the only way you can trust the loop to run unattended.
All right, section 4, building a real agent. Let's ground all this theory in reality. What does it actually look like when a developer builds a self-sustaining loop to automate their real-world morning workflow?
Picture this timeline. At 9 a.m. sharp, an automation triggers the loop to triage yesterday's bug reports. By 9:05, a subagent explores the code base to research the fix. At 9:15, a different maker agent drafts the actual code. At 9:20, that adversarial reviewer agent steps in to verify that all the tests pass, and by 9:30, a connector opens a pull request on GitHub. Think about that. You, the human, designed the entire flow once, but you didn't manually prompt a single step this morning.
Now, let's see how this builds into even more advanced automation. According to LangChain, there are essentially 4 levels of loop craft. Level 1 is just your basic agent loop. Level 2 adds the verification loop to check the work.
Level 3 is the event-driven loop, hooking into those real-world triggers we talked about. But level 4, that's the holy grail, the hill-climbing loop. This is where the system actually reads the traces of its past failures and updates its own tools and prompts to get smarter over time. It literally automates its own improvement. Section 5. Why loop engineering wins. Looking at these advanced loops from a macro perspective, it becomes incredibly clear why this shift is completely changing the landscape of software development and knowledge work.
The transition is just striking. To be clear, prompt engineering isn't totally dead, it's just being stacked. Instead of you manually driving every single step and hitting that massive productivity bottleneck, your job shifts to designing the overarching system. You define the success criteria and the rules, and the AI performs all the iterative, exhausting labor. Your leverage as a worker absolutely skyrockets.
And the benefits are massive. Because the loop rigorously verifies its own work, you get better quality code. Because it runs autonomously, you get true automation and way faster development. But honestly, perhaps the biggest win is just less manual exhaustion. You are no longer sitting at your desk waiting for a progress bar to finish just so you can type the next command. You can be running multiple automated workflows simultaneously.
Which brings us to our final section, Section 6, the challenges and the future. Look, before you go handing over all your projects to autonomous loops, we have to issue a crucial warning. Letting these systems run completely unattended comes with some very unique and, frankly, very expensive risks.
Now, what's really interesting about this slide is the concept of fuzzy success criteria. If you tell a loop to make my Python code run faster, well, that is an objective, measurable goal. The loop knows exactly when to stop. But if you tell a loop to write a highly engaging article, that's fuzzy. I mean, how does it measure engagement? Without crystal clear objective success criteria, a loop won't know when it's done. It will just spin, infinitely, hallucinate progress, and burn through a massive amount of expensive API tokens in the process.
And there's an even deeper, much more human risk here: comprehension debt. If you let an automated loop constantly ship code or content or analysis that you never even read or review, you slowly lose understanding of your own project. It's a phenomenon called cognitive surrender. You basically stop having an opinion and just accept whatever the machine outputs. If your loop breaks a month from now, you won't even know how to fix it because you didn't write any of the underlying logic.
Which perfectly brings us to this powerful concluding thought from Adi Osmani. Build the loop, but build it like someone who intends to stay the engineer, not just the person who presses go. Loop engineering is undeniably the future of how we will interact with AI. It grants us just incredible leverage. But remember, the tool is only as good as the system architect behind it. So are you going to use loops to master your work at an unprecedented scale, or are you going to use them to avoid understanding your work altogether? That's the real question you have to answer. Thanks so much for tuning in, and we'll see you in the next explainer.